The next topic is how to use feed-forward in a boiler level control. This is a very simplified three-element level control, and we want to use feed-forward in order to control, and we use a very simple simulation program, and we will perform simulation, and I'll show you how to use feed forward to make the this control system stable if you have any variations in a steam. The boiler level is controlled by amount of steam, steam demand, the amount of steam that is exported. Steam flow is indication of amount of steam exported, and we need to support the steam drum with the proper fresh water via this flow control. So in a normal operation, we consider we have a cascade level control. Cascade level control is commanding the flow control, this FC402, to regulate the fresh water. This is the fresh water, and after being boiled, steam is transferred. So if we don't consider the feed forward, and any variation in steam is ignored, and fluctuation in the steam will have severe fluctuation effect in the level, because when the steam is high, the level of the boiler is getting low, and it's possible to shut down the level if it's high, and it takes time to compensate, and if we cannot compensate, it's possible to shut down the boiler due to low level for water low level. So we need to consider the steam flow as a feed forward, as extra information. In this example, we considered if steam flow is fluctuating, and we want to use this feed forward in order to inform the master level control, and by regulating the water flow, we compensate. In case of more demand in flow, we need to increase the inlet flow of fresh water, and in case of lower demand, we should close the flow control valve and reduce the amount of water to the boiler drum. In this case, we use the positive feed-forward gain. Our FF gain is +1, and we use the steam flow for extra information regarding the load variation. So I explained the program in the delta V environment. So we have only one control valve and 3 transmitters. This is the master loop, a slave loop, and this is the feed forward information, and we have the positive feed forward gain. So we should go to the delta V program. We have delta V level control and delta V level simulation. Simulation is somehow a water accumulation and variation, creating variation in the steam, generated steam or output steam. But our focus today is mostly on the control part. And let me go online. So we have one control output, that is the action on flow control valve. This is the cascade structure. The water flow control is in cascade mode, and this is in automatic mode. And let me check the set value. The set value is 0. Drum level is scaled from -5 to 5. Mostly the boiler drum are somehow they're not huge like tanks. They are very limited space, and here if we want to the 0 is the middle. If we want, it's possible for us to increase the set point from -5 to 5. Let us change the set point. This is the action on the input flow, water flow, and you know, the green curve is the level. The green is the level. You can see that variation in steam. Variation in steam has its own effect in the variation in steam has its own effect in the level control. Let us check. You're seeing the changes. Let me change the master control from automatic to manual. I want to disable the first. Let me disable the FF enable, and let's see. And again, let me change it to automatic mode, auto. Let's see what's the effect of feed forward. You can see that when we disable the feed forward, the control quality is damaged or reduced. So we are in automatic. Let's check several cycles. Let me return the enable the feed forward. I need to put the PID in manual. FF enable the feed forward, true, and change the mode to automatic, and wait for a while to reach to the steady state. And because we were in manual, and now we are going to automatic mode. So being in using feed forward is a great advantage. In this example, you can see extra information from external load change. Steam demand is changing because we don't have any information about the steam users, but flow of steam is a great and valuable information to help us to get the best reactions. You can see that steam flow is fed to the feed forward value, and by enabling the feed forward in P51, we are making a steer. You can see that the level control is getting more stable, less variations in the level control. It's a great tool. It's a great tool. It's also possible to implement same behavior by MPC. It's also possible to use MPC for dynamic load changes, but for this application the easiest way is using the steam flow as the input for a feed forward. It's a very good example, and I highly recommend you to explore this example and function test that I will provide all files, and you can check all the details. Thank you for watching.